role does alerting play in a monitoring infrastructure?
So alerting is basically the bell in the fire alarm. It notifies us. It's the human-machine interface that notifies us that things are going sideways. And in some of the smaller systems, like your self-contained fire alarm, the bell is the same sort of entity that decides whether or not there is a problem. So it's problem detection and alarming. And in some of the larger, systems, just like in a larger facility, the logic of whether or not to ring the bell is somewhere apart from the bell. But in any case, alerting tells us that stuff's going wrong. There are different mechanisms. SMS is obviously a really popular one. Email is another. And the webhooks and web services interfaces and integrations to notification services like PagerDuty and Flapjack are obviously getting a lot more popular, like lately.
And why is it so difficult to design an effective system, and what drawbacks have you experienced from poorly designed systems?
So, like making the bell is actually not a very difficult problem. It's a much more difficult problem to figure out when to ring it. And in terms of actual features, tools engineering, there are definitely features that you'd want to implement to have an effective alerting system. And these are things like what types of criteria you can use to sound the alarm, and some alert fatigue type features like delay timers that ensure that you're not being paged more often than you should be. But I don't think in web operations, rolling a better alerting system is going to solve our problem with alerting. I think that our problems are very much wrapped up in a series of, like many things in web operations, our problems are basically wrapped up in a series of anti-patterns that we've inherited from the generations of engineers before us. And I think that as a result of those anti-patterns, we have garbage input to a lot of the notification systems that we use. I think that we spend a lot of our time monitoring the wrong things, things that we don't actually care about, like disks and CPUs and network I/O, as opposed to things that we actually do care about in web operations, which is like inter-service latency, queue sizes, and things of that nature. And I think that the tools that we have at our disposal don't make it impossible to monitor those things, but they make it very easy to monitor other things. And therefore, we wind up sort of in this place where we're doing a lot of watching stuff we don't care about, and our alerts suffer in kind.
You've recently redesigned your alerting system at Librato. What did you change?
Yeah, we've actually implemented a whole lot of features in our new alerting subsystem. And these are things like compound criteria, so you can alert on criteria from multiple sources or multiple metrics. And that makes it possible to do things like, if I'm an admin and I've noticed some correlation between some CPU here and some latency there, I can craft an alert that allows me to alert on the combination of those two problems. But I think functionally, the really important stuff that we've implemented is actually invisible to the user. We made at Librato, we made this sort of acknowledgement very early on in the design of our system that monitoring is actually a signal processing problem, and the design of our metrics platform very naturally sort of flows from that realization, except for our alerting component. Our alerting component was very much sort of a one-off type of a thing. We were batch processing already persisted metrics looking for alerting criteria. It wasn't like a stream processing type DSP sort of design. And this last iteration on our alerting system made our alerting part of the stream processing system, which has allowed us to do some really interesting things behind the scenes. It's allowed us to, for example, craft the alert criteria as functions in a stream processing system. So going forward in the future, we'll be able to experiment very easily with a lot of different types of alert criteria, because it's basically functional at this point, which is very nice. So.
And how does your new design address alert fatigue while still notifying operators what they need to know?
Yeah, we have a whole bunch of features, like I said, that are in there that address things like alert fatigue. We have I don't remember what they're called, the trigger timer that basically says, hey, don't alert me more than X number of times per minute. We're working very hard with some of our integration partners like PagerDuty and VictorOps to allow things like the admin to acknowledge alerts from their pager and have it roll back through their notification escalation system and into us. So yeah, alert notification is definitely a huge problem. And I think this is actually part of the work that we're doing with trying to figure out alert fatigue. A huge win is going to come from, I think, educating web operations engineers about the types of things they could be monitoring to improve their input stream, so they're not notified about things they don't care about so often. So we've kind of taken to the road in that respect and are kind of trying to get the word out, like, hey, tell the story of how we monitor at Librato. There are organizations out there that are extremely effective organizations at monitoring with today's tools. And I think one of the hugest risks with alert fatigue is this notion we have that we somehow need to solve this problem with like artificial intelligence or like machine learning algorithms or dynamic thresholds. Like maybe thresholds are the problem. I think that alert fatigue definitely causes us to want to process the alerts when I don't think the alerts are necessarily the problem. I'm not a Luddite. I don't think that machine learning is bad. I think that there's some amazing work going on there, but I also think there are some huge wins to be had just by making the actual input signal that we're sending to our notification system an effective telemetry data stream. So.
Something else you've done is separate the alerts as their own UI entity on the dashboard alongside the metrics and instruments and whatnot. Why is that important?
So there are a lot of tools out there that incorrectly make this relationship between a host and a service and an alert. They sometimes literally, like the alert is actually a bit of configuration that is attached to either a system or a service. And the biggest problem there is you can't craft an alert that contains input from multiple entities, right? In that sense, when you tie them together, when alerting is not sort of a first-class entity that I can actually interact with, that I'm very restricted in what kind of criteria I can craft. So by making alerting this thing that you can say, okay, I would like to generate a new alert in the same way I'd like to generate a new metric, I can take that top-level alerting entity and I can bring in whatever other entities I want it to relate to.
So you can isolate exactly what you're being alerted about.
You can very precisely craft an alert that matches the model for your problem, right?
And Librato has also been doing interesting work in metrics-driven development. How does that work, and how does it compare to test-driven development and behavior-driven development that we've been hearing about?
That's a really awesome question. There are a lot of DDs, there are a lot of driven developments that seem to be popping up. So I think they're very related. It's sort of a related yet nuanced sort of a situation. So with test-driven development and behavior-driven development, you have this model where you're making the realization that you're building a thing, and that this thing that you're building is sufficiently complex that you can't necessarily tell ahead of time what it's going to do. Like if we're making a hammer, we pretty much we understand like the operational characteristics of a hammer. We tie some metal to a stick and we're good. But when we craft something like a web service, like a worker service that's going to interact with other services in the wild, we're not necessarily sure, given some type of input, what the output will be. And so test-driven development sort of acknowledges this up front, and we say, listen, we're building something very complex. We want to make sure upfront that we understand how it works. And by how it works, we mean when we give it, input A, we expect output B. And then we craft the tests ahead of time before we put it into production to make sure that not only when we create it that it does what we think it will do, but that it will continue doing what we think it will do as we change it going forward. Metrics-driven development makes a very similar sort of realization, which is that when we put our worker in the wild, we can't really protect it. We can't control what happens to it. It has to interact in the horrible reality of meat space. And so what we're trying to say is kind of the same thing. We want to reason up front about the thing that we're creating, that we care about, and we want to make sure that that thing continues to operate within a set of expected operational limitations. We do the same thing in all kinds of other engineering disciplines. Like if we're measuring a human heart, we want to make sure that it doesn't beat more than 160 times per minute. Or if we're launching a satellite, we want to make sure that its orbital velocity doesn't exceed 7 million kilometers per hour. We're doing the same thing with the software that we're building. We're taking this worker process and we're saying, listen, this worker process always needs to respond with a 99th percentile interservice latency below X. And then we're building the instrumentation we need to manage those limits, to watch them when they go into the wild. It's not debugging code, it's a functional part of the software that we build. We embed it in the software, we throw our software into the wild, and we continue to sort of monitor those operational limitations, through the life of the thing we build. So yeah, in web operations, we're very much building balanced equations. And theoretically, as long as we keep them in balance, they could run forever. But for the horrible reality of meat space, the entropic whatever. So yeah, MDD is basically just a way of like embedding monitoring into the development process so that we can get a steady stream of telemetry from the things we build to make sure that they remain in balance, and obviously to correct them when they start to go sideways.
Interesting. Well, thank you very much for talking with me today.
Thanks for having me.